My YouTube channel JavaByMK. So in this video I will continue with my Kubernetes series. So as I discussed on my previous video, I have explained how uh, Kubernetes architectures, all the components. So the last point which I was continuing with was service. Okay, so as I discussed in my previous video, that service is basically provides unique IP to a particular microservice. Okay, so as I discussed that for a one particular customer, suppose for customer service, it can have multiple pods. Okay, and each and every pod will have a separate IP. Okay, so based on the requirement, a pod of the IP changes. Okay, so in order, so we need service so that it provides a cluster IP associated with one particular service. Okay, so then the question is uh, pod how pod and the service interacts. Okay, so for that we have service YML. Okay, so this is one project I have in customer service. Okay, so here I have already explained customer deployment.yml. This is basically YML using which we create the pod. Okay, and we give the selector name as customer. Okay, so similarly we also have customer service.yml, and this is basically uh, uh, mm, how we create service in a Kubernetes for a customer. Okay, so you can see that this is common in both YML. Okay, so this is how pod understands that yes, this is my service, this is my cluster IP. Okay, this is how both understands that they belong to the same service. Okay, so same microservice. Okay, so basically next point is like now we understand a lot about Kubernetes architecture, right? Like I have already explained, I have already explained. Uh, 1 minute. I have already explained API server. I have already explained scheduler, controller, etcd, then pod, and then kubelet. Okay. So now I will continue in this video with Ingress. Okay. So why Ingress is required? And what is the use of this Ingress? Okay. So just like um we need some routing mechanism. Okay, so we have already provided cluster IP to each and every microservice like customer service, product service. Okay, but how we need some mechanism also for the routing. So for this purpose Ingress is been introduced. Okay, so in this way, in this using this, we Kubernetes will understand that if this request comes, then it will go to customer service. If this request comes, then it will go to product service, like this. Okay, so this is how it is saying, like Ingress only defines how traffic should be routed. Okay, it is just a mechanism. Okay, so we have nginx Ingress controller. So it is basically runs as a pod inside the cluster only, but its responsibility is to route the respective request. Okay, so suppose customer, so this customer comes, then it will Ingress will redirect it to customer service, and if product comes, it will redirect to product service, like this. Okay, so it checks the host versus and path both. Okay, so how it works, like and like how the request comes to Ingress, then it goes to service, and then from service it goes to pod, and how it the response goes back is from pod to service to Ingress and then to user. Okay, so I also have a YML. Okay, so I have YML here also. So in this YML you will see exactly what I was talking about. We have this ingress.yml, and it will be basically provide all the paths. Like you can see, we have set the rules here that if the host will be ecommerce.local, and if the path will be customer, then request will go to customer service. If the path will be product, it will go to product service. If the path is sellers, then it will go to seller service. Okay, like this. Okay, so so this is how Ingress works. Now we will continue with Kube-Proxy. Okay, as I mentioned in my previous video also, that Kube-Proxy is basically responsible for the networking inside the worker node. Okay, so like as I said, like for the routing we will use Ingress, but it will be outside of, it will be basically outside of the worker node, but Kube-Proxy is basically is inside the worker node. Okay, so service and endpoint. So how Kube-Proxy works internally, step by step. So service and endpoints are created. Okay, so service and endpoints both are created. Okay, and Kube-Proxy watches the API service. Okay, it continuously watches and it checks for the service and endpoints. Basically service, like I have already explained. And this is something very related to IP versioning. We have two IP tables. I will not go much into these details. So basically ClusterIP does not belong to any pod. Kernel redirects traffic. Okay, incoming request. So how it works, see, client the request comes to service IP. From service IP it goes to pod. Depends on which and what mechanism internally it uses. uh, Traffic is spread across pods. Like if the request comes, right, so it should go it will, Kube-Proxy will decide the request will go to which pod. Like there will be multiple pods, right? So it will go to which pod. So those things will be decided by the load balancer, which is there in Kube-Proxy. Okay, so Kube-Proxy makes services actually work by programming traffic routing inside the kernel. Okay, inside the it is at the pod level. Okay, so which pod one request will go, it will be decided by Kube-Proxy. Okay, so that's all for this video. In the next video I will discuss about the all the commands that we use in Kubernetes. Like if I give a high level view, then it would be like all these commands. Okay, not only these commands, I will explain what these commands does. I will also explain by a live demo. Okay, so thank you for watching.